Let x be a random variable which assumes only two values. So that means xi can only take two values, and representing the occurrence of success and failure in the probability with only two outcomes. The probability of getting successes is p theta. So that means like xi is Bernoulli. So expectation of xi, if we consider that is p of theta, and variance of xi will just be p of theta into 1 minus of p of theta. So now like p of theta is given as this function. So define an estimated t which is sample proportion of successes. Then which of the following statements is are correct? So by using like weak law of large numbers, so we can see that like t is 1 by n, summation I is equals to 1 to n xi. So in probability it goes to expectation of xi, which is nothing but p of theta. So that means t converges in probability to p of theta. So that means if theta is rational, so if we're having like theta being rational, so p theta is equals to theta, so that means t tends to p in theta, so that means t is consistent for theta. Whereas if we consider theta is irrational or algebraic irrational as given in the question, so p of theta will be 1 minus theta. So t is tends to 1 minus theta in probability, which is not equals to theta. So that means t is not consistent in this case. So that therefore like t is not consistent, because like consistency of an estimator is required for every possible value of the parameter in its parameter space. So now like since there exist certain parametric values like the algebraic irrationals for which this t is not converging to theta, so therefore t is not a consistent estimator of this theta. So next like we also have to check whether it is having like MLE or not. So if we